So this video is on the assumption checks, and assumptions are basically tests that we can do to ensure that our statistical test that we're conducting, in this case, an independent samples t-test, meets the requirements for that test. So if you don't violate the assumptions, if your assumptions are met, then you can say that it's a valid reason to conduct that test. I will say that there are some people who feel that the assumptions are assumptions for a reason, and so you just let the assumptions be, but you can check them. And so my opinion is why not? It's good practice. So one of our assumptions for an independent samples t-test, you can see I already have the test here. I conducted this in a previous video. One of our assumption is the homogeneity of variance test. So I'm going to go to this assumption checks right here. I'm going to click on homogeneity test. And this is the Levene's test for homogeneity of variance. As you know from lecture, I love that word. It just rolls right off the tongue. So with this, we're looking to see, are the differences in each group about equal? So are we comparing, you can think of it as kind of like comparing, are we comparing apples to apples? Are we looking at groups that are similar enough to compare? The idea is that if they're really, really different, we should try and adjust for having more error in our test and be more conservative, make it harder to find statistical significance so that we avoid making a mistake, making a type 1 error. So for this, the way that we interpret this is that you can see homogeneity of variances test here. It gives us a p-value. And as Jamovi helpfully tells you, a low p-value suggests a violation of the assumption of equal variances. So if you violated the assumption of equal variances, your p-value would be less than 0.05. In that case, Jamovi actually gives you a little note up here underneath the original test. It'll tell you that you need to conduct a different test. And so if you violate this assumption only, you can conduct this Welch's t-test instead, which I'm not going to cover in this video, but just to show you how you can add that in. Now, the other assumption that we have for the independent samples t-test is that we have normality, that our dependent variable is normally distributed. And so this is, again, it's an assumption on that is what we built this test, not what we, what people built this test on. And so we have this normality test. It's a Shapiro-Wilk test for normality. You can also use a QQ plot, but I'm going to stick with the Shapiro-Wilk test just because I think it's a little bit more common to use that, at least in my experience. And so this test, again, a low p-value tells us that we would reject the assumption of normality, but our p-value is very high. So we have a very normally distributed data set. We don't need to worry about violating this assumption. If we violated normality, or if we violated normality and homogeneity of variances, we could do a non-parametric test. We could do the Mann-Whitney U, and you would just click that right here. Again, I'm not going to go through how to interpret that, but that is how you test assumptions. And just for fun, you can see this QQ plot. If the QQ plot is showing that you have non-normally distributed data, it wouldn't be along this line. It would look like it was pulling away from that line at the end, or other irregular looking things that don't look like that line. So again, that is checking assumptions for the independent samples t-test. So if you don't violate them, then you just continue with your test and interpret the results, which is what we would do in this case because we have not violated any assumptions.